Check. Yeah, okay. That'll work. You're all good? Yeah, I'm just going to sit. Screw it.
All right. So, without any further ado, I'd like to introduce you. Please give a warm ShmooCon welcome to Carl, who will be talking about post-exploitation in Go.
Hello. Yeah, I guess I should be standing, but the podium sucks, so I'm going to sit. Screw it. Everybody hear me okay? Awesome. So the title is on the left. Make sure everybody's in the right place. You know, what do you mean this isn't Jeff Moss's talk? Yeah. Just a quick primer on presentation style. I talk really fast in general, and I'm on stage in front of a bunch of people smarter than me, so I'll probably talk about 5 times as fast as I should. So feel free to just yell slow down really loud, and I fucking will. Also, I swear, get used to it. And any time is a good time for a question, because I will go on tangents and I will totally forget, so your question will go unanswered, so just shmooball me in the head or something if I don't stop. So this talk is about implants. Those of you who work in the Fed space are probably familiar with the term implant. Those of you who aren't, an implant is basically an interpreter, which will make sense to those of you who know what that is. For everybody else, you're going to get a quick primer on it in about 5 minutes. So if you already know what those things are, just take a drink and relax. So what is an implant? So for the purposes of this talk, when we talk about implants, we're talking about post-exploitation stuff. But specifically post-exploitation stuff, usually in this talk, that is autonomous. So not things that reply with a shell or things that are going to give us some TCP/IP sockets that we can kind of mess with. We're talking about largely autonomous things that will go in, do what they need to, and get out, and the only time you're going to hear from them again is when they're done running. So this is kind of a crude, kind of a simile, right? So your exploit or your PSExec or meta-SSH or whatever you use to access your victim, this is the thing that we're putting in the victim. All right, so other people's implants. So there's basically 2 forms of post-exploitation stuff, whether it comes in the form of a self-contained binary or really exotic shellcode. There's basically the legal ones and the illegal ones. So the non-shady ones are usually not autonomous friendly. They're designed to get you a shell as quick as possible. Some of them come with Packer add-ons and covert channel, but at the end of the day, they're designed to get you a real-time control interface for a system or group of assets, which is totally different than the stuff that the bad guys does. The only exception to this in terms of explicitly legal programs that I'm aware of are flat-out spyware, stuff like FinFisher and stuff like that, which is technically legal, but not safe for pen testing for obvious political reasons. The illegal ones are illegal, usually, and even if they weren't, the problem is that you can't trust them because you don't really know what they do, right? They're distributed in a binary format. Yeah, you can reverse it, but that's just not practical for time's sake, right? Like, it's probably owned, it's probably backdoored, it's way too much money to deploy on a client site, and you can't deploy it on a client if you're, performing in an assessment environment because nobody's going to let you run malware on their shit. Both of them suffer from the problem of AV usually has access to both, and that's pretty much all they do all the time is try to make them not work. So having your own, would be nice. So these are just some examples, in case the categories weren't clear of stuff in both categories. So why not write our own? Well, because it turns out writing your own is a massive pain in the ass. There's a shit ton of platforms, right? Like, your program wakes up and it thinks it's on a computer and it's on a tablet. It thinks it's on a tablet, but it's a different type of tablet, or it's a tablet without, with 2 disk drives instead of 1, or it doesn't have a C drive. It has some weird, embedded thing. Like, it's a pain in the ass, right? And who knows what operating system's running on it, because operating systems run on everything these days, right? You can put Windows on a Mac, you can put Linux on a Dell Windows shipped PC, like, Windows is in phones, all the things. And processors are a gimme, right? Like there's ARM MacBooks now, like software dev is hard, like legitimately difficult. And writing a payload is no different. So language options. So like anybody who's done a lot of reverse engineering on actual like criminal malware is probably familiar with Delphi because it's the malware trick of it's really annoying to reverse because it runs inside an emulator. So you can just cake on bullshit and confuse reversers. It's usually pretty popular for old school malware, but there's a ton of limitations, especially if you're writing Delphi bugs for cross-compiling on other operating systems. And generally writing the three languages, the other three languages that are on this slide are a massive pain in the ass. Yes, there's a bunch of Haskell nerds in the audience. I'm looking at you directly. I don't care. Writing Haskell and formulatic direct functions for doing data exfil is stupid. Nobody wants to do that. I don't want to do that, right? And the other everybody's option is C++ because it runs on everything, or Java, but no, right? Like, raise your hand if you've written malware in C++. That shit is hard, isn't it? Oh, don't shrug at me, says the guy who's had payloads banned from CCDC before because, I can't tweak this in time because it's in fucking C. Oh well. And yeah, fuck Java, because fuck Java and emulators and all that insanity. Yeah, and then there's the problem of using, obviously if you're building a payload, you're going to want it to be in a compiled language so it runs on everything. But building something in a compiled language out of tactics that are, all of us are learning about in the communal space on the internet, using, questionable methods, non-questionable methods, whatever, is kind of like building a Rube Goldberg machine, right? Like you have to reverse engineer a bunch of other people's finished quote-unquote products and take those parts out and then build something with those parts. That is a shit ton of work. And then there's the C2 problem, right? Like, phishing should be the easiest job for a consultant to do, yet spinning up the server for the website ends up taking 90% of the time. Because SSL and domain origin and signatures and. So all this stuff is a massive pain in the ass to get right once. It's super time consuming. And then even if you get it all right and you do all the work in the beginning, somebody changes something and then it's all fucked. So this talk is basically on how maybe we can make this process not suck. This is our goal here, right? Okay, so to make this not suck, what do we want? All right, well, first of all, this guy is the devil, and you should just kind of know that. If you don't, just trust me. Disk.io is the devil. It will cause problems. Getting reverse engineered is a fact of life. People are going to take your binary apart if it's any good. If they're not, it's probably not doing what you want. Always include a big red button. Frankly, even for legal or illegal work, at the end of the day, you're going to want to be able to hit a big red button and make your payload go away. Feature iteration has to be fast and effortless because otherwise you will be left behind and you just won't use it. And you'll compromise other functions. Either you'll use lazier C2s, you'll get lazy about your search, you won't sign your code. And all of these things make for bad OPSEC because we're all human beings as much as we want to be elite hacksaws. And human beings, we're lazy. Like, I don't know about you guys, I'm lazy. I comment my code because, I don't know about you guys, but I wake up on Saturday and I'm like, what does this do? I was too stoned to remember, That's why I have comments in my code. So, OPSEC is a thing. And pretty much like the online pastor of all things, OPSEC is the Grok these days. So I put a picture of him at the bottom with his Twitter face in case people don't know who he is in real life. That's actually him on the left. No, he's not an old Chinese guy. So enter the user land loader. Anybody watch Rick and Morty? All right, so you've all seen this episode, right? It's like the whole civilization inside the battery. Okay, so that's basically what a user land loader is. What the hell is that? Does anybody, who in this room does not know what a loader is in terms of operating system context? Really? Every single person knows what a loader is? All right. Do you all know what a user space loader is?
Explain it anyway.
Fine. Okay, well, you guys know what a loader anatomy is, so I guess I'm not going to spend forever on it. But yeah, so this is, a loader is the part of the operating system that loads programs. It interprets a binary format, it makes room on the stack for your process, it copies all the stuff where it needs to go in the process, and then it links all the things, and then says, go, do stuff. So pretty much every natural loader out there in the universe will only do this from a file system. It'll almost never do it from memory, and if it will do it from memory, it usually won't give unprivileged access to, or a regular user permission to do it from memory because malware reasons. The only exception I'm aware of to that is the Bionic loader that's inside Android, but there's a ton of reasons why they try to make you not use it, because the only things that successfully use it regularly are usually really shady. So a user space loader is basically a program that does exactly the same thing, only it's a program, so you can make it run from memory if you want to, and it doesn't require any operating system calls and things like that. The big deal is that if you build a user space loader that includes a binary file interpreter, there's nothing stopping you from calling pre-compiled code in its compiled state. You can take whole tools, whole binaries, and just stick them in memory and go run this thing, and it works. So by doing this, we solve a lot of problems for ourselves, right? Like we don't have disk I/O because we're reading from memory. Reverse engineering, we're still getting reverse engineered, but as probably any reverser will tell you, looking for a random function call that might be the loader and then trying to take apart what it's loading without knowing the binary type or whether or not it's packed is a much more involved process than taking apart code in a regular context. So we're helping with that second one. We don't have to worry about the big red button because we're using somebody else's code, so it's pretty easy to remove. It's all self-contained. Iteration being fast is a given, right? Because I can just download somebody else's tool and use it. Oh, it doesn't work. I'll go use another one. That took 10 seconds. And that makes all these things admin friendly because you can use tools that have established protocols for talking stuff back, and that's good OPSEC. That means these are fast and we'll actually use these things. You also get tons of other bonuses from user space loaders. So they're run in memory, which is just good for speed and all kinds of other stuff. Usually all the threat endpoint protection tools out there, like your Cylances and your McAfee N protects and your, what's the other one? The one that FireEye sells that's on board. I don't remember. It's like Mandiant, some crap. Pretty much the way all those things work is they all look for API calls in the operating system. User space loader doesn't make any. So it's not going to show up in a process list. It's not going to show up as a resource. You're just kind of invisible. So it's nice. All right, so to recap, open source implants are shady. Building your own is annoying, but user space loader makes things easier, and that means we can use other people's tools. So this is a good thing, right? This is very little code. It's easy to maintain, and does all kinds of horrible. So how do we implement this? Okay, so on Windows, use that. No, really, don't bother writing your own, just use that. It's super well maintained. It's actually used in Py-to-exe, so it's been fuzzed a bunch. And AV vendors still aren't flagging all the binaries we make with Py-to-exe, so clearly it's not getting flagged anytime soon. The only caveat to using this is that when you use it to load fully composited binaries, it's originally designed to load DLLs and not PE files in general, even though they're the same thing. So I have a version of this that is modified to allow arguments because you don't usually pass arguments to a DLL. And at some point today, when I'm not shaking and terrified from being on stage, I'll post that code. But yeah. On Linux, it's slightly more difficult, only because there's, like all things on Linux, there's too many options instead of not enough. So those are two. The OS kit one is kind of more of a debugger one, so there's a bunch of overhead. Probably not practical to use in a payload, but you can. I've done it. And the libelf one is kind of the given example. I know it's probably really hard to read on the slide, but that URL is somebody on Stack Overflow actually implementing a user space loader in Linux using elflib, and it's only about 60 lines of code, even though it's all in C. So there's that. There's Bionic, which I talked about earlier, which runs on Android. Or you can just get an ELF parser and build it yourself, which on Linux is pretty easy since it's open source. You can just read the loader code and do it. One caveat on Linux. Linux binaries assume they're all getting loaded in the same place. So unless your payload contained binary is compiled position independent, you can get errors unless whatever you're running is statically linked. Hint, the language we're going to talk about in a minute, everything is statically linked. On OS X, I haven't messed with it that much, but this guy did a really awesome talk on it at Black Hat, and by following his slides in about an hour, totally had a user space loader routing. So I'm not going to bother explaining the internals of that. You should just go watch his talk. It basically works by, he wrote his own execv that runs from memory, because Apple released enough of it that he could just do that. So he did. So now we're going to talk about, well, we're going to round around to my example. So I have found that all of these things are really easy to do in Go. Go solves a lot of problems for you. It's cool. So Go ships with a compiler, an alternate compiler for it called Cgo. Cgo is an interface to GCC. Amongst other things, this means that you can take C code and you can call it directly in Go. You just import C from any OS, any of the supported OSs. And its supported OSs, the ones I have listed on the slide is not even all of them. It works on, it does work on Plan 9. It'll also work on bare metal if you compile it for Plan 9 but build it against the bare metal SDK. There's I don't know, there's like 8 or 9 other operating systems that it runs on, but it runs on fucking everything. And it also comes with Go runtime, and Go runtime basically makes writing Go kind of like writing Python. You have garbage collection, you can use string literals, you know, the syntax is pretty simple, it's nice. Also, you get Go routines instead of manually managing threads. Oh my God, saves so much time. Like, Go run some function instead of pthread, lines and lines of bullshit. And it natively compiles to all those operating systems because fuck emulators. Fucking Java. So I was going to try to be awesome and compile it in front of you and show how to use it, but it turns out setting up a dev environment on a Windows XP VM that is from your friend and cracked doesn't always work, so I made a video instead. So this example is using Go Mimikatz, which is a product I released on GitHub a while ago. And this is kind of, well, this is the source code. There's a rudimentary support file that comes with it. Oh, that's kind of hard to see. So this stuff up here is some Cgo code that just loads memory module. It's only 3 lines, and they're just compiler flags. I'm literally just pulling in the .h. And the rest of this code that looks like it does a lot of fancy stuff is really just pulling a one-time pad out of memory. Because when writing this, I tested this on a corporate machine and had corporate AV problems, so I couldn't keep Mimikatz on my computer long enough to compile the binary. And so I chose the internet looking for a solution to this problem, and turns out that somebody wrote a library called Go bin data for Go that is for storing static assets as giant strings inside a Go program, because there's a lot of web developers who are using Go. So I just wrote a one-time pad thing that takes a binary file, splits it into 2 one-time pads, and then I used his storage system. So I just go pull this file, and it stores it for me and gives me a byte slice. So that's what all this code is right here. And then the actual business end of the stick, where stuff is getting called, if my video will hurry up, is just this one line, the c.memory call entry point handle. That's it. That's me calling any binary in the world with a single line of code. I can do whatever I want with the output. So if they iterate on Mimikatz tomorrow and add some new awesome command, sweet, just recompile it. Function iterated. And so that's kind of how it works under the hood. It's all public on how to compile it. This example is me plugging in a USB stick with Mimikatz on it, just regular. Take forever. And you'll see antivirus, as soon as I enter the folder, immediately isolate the original binary. And this is just downloaded from the site, not packed, modified, whatever. And as soon as I click on it, like, oh my God, freak out. That's not okay. And so this demo, this isn't even us using the exfiltration data to do, this isn't us exfiltrating or do anything fun. This is just an example of what I can do with a single line of code. And just by using a single line of code, I automatically get packing, right? So this is me going into my Go source directory and running the Go Mimikatz binary, which was compiled using the other binary. So this should set off the same AV, and it just works. That's it working. Dumping hashes and all that jazz. Yay. All right. So I talked really fast, and now we have a bunch of time. So does anybody have interesting questions? Come on. You all said you knew what a loader was, so you got to have interesting questions. Yeah. Yeah, that's true. But even still, it was only, I think it's like 50 lines of code when totally implemented, and calling the executable is still one line.
You hinted at the notion of doing actual autonomous functionality, but you didn't talk about it at all. Care to expand on that piece of it?
Sure. So I talked about autonomous functionality. Sorry, the question was for the recording. Can you talk about autonomous functionality? So yeah, what are some annoying things when doing autonomous functionality? Well, threads is one. The one line of code that I showed in my example is a Go function. So that means I can run it as its own thread without system time. And I can do that forever, and I don't have to use any system thread libraries to do it. So things that are monitoring API calls for thread calls and stuff, no problem. Also, being able to use whole composited tools in your tools means that why do you have to exfiltrate so early, right? Like if you have a payload and you're on a job and you're like, I just want a shell. Oh, why do you want that shell? Oh, because I want to drop credentials and then I want to use those credentials on all the other attached systems and see if there's something else. Oh, well, what are you going to use to do that? Oh, ps-exec. Okay, well, is that a binary? Yeah. All right, well, oh, damn it. Well, just take ps-exec and put it in the binary and ps-exec your answer, and then you don't have to write exfiltration. And this is happening, isn't it? God damn it.
How'd he do? He's waiting for this. So, are you done? Is this hot?
Yeah.
It's hot enough. I can yell. So, a few years ago, I was at DEF CON, and we had run a contest. It was the first year of Hack Fortress, I think, and we were up on stage, and we were at the Riviera. And I'm standing there, and I'm thanking all these people for all their help, and I haven't announced the winners yet, and I thanked the hotel staff. And I got confused and thought we were still at the Alexis Park. I said, I'd like to thank the Alexis Park staff, and everyone's like, boo, drink. I'm like, I got nothing to drink. Keep going my little thing. Maybe 15 seconds later, Virus walks up and is like, here, have this. And he sets a handle of something down in front of me. I'm busy, I'm distracted.
I tried. I pointed the logo towards him so he'd know what it was. And I looked around in the front row to see if anybody else had anything human to drink, and nobody else stood up.
So he hands me this handle, and I'm like, all right, and everyone's chanting drink. I'm like, I can't do this. I can't continue unless I drink this thing. So I'm not paying any attention. Spin the handle around, open it up, tip it back, and as I tip it back, I see in the label it says Everclear. I was like, holy shit, I'm gonna die. So, and I tell you, Everclear, it hurts. Like, it really, honestly, it's not meant to shoot like that. And I was thinking, like, I'm gonna be serious. And I took a couple big gulps, and I could not stop the process. So my face went flush. I started to lose the ability to breathe. I was trying to thank people by their handle. I couldn't remember them. I used their real names, and then I ran off stage and, like, sat quietly in the hallway. So ever since then, I've not liked virus. And in fairness, I'm not going to make you drink it today because I know it wasn't your intention.
No,
that.
It's all right.
You sure?
Oh, yeah.
You want to do it like a civilized human?
No,
Okay.
no. As a 949 member, I'm a professional.
You know how to open it?
Yeah.
Okay. Oh! Oh my God! All right, I'm gonna leave him alone now. Hey, good job.
Nobody saw anything. Where was I? I think I was done. Something autonomous functionality, something or other. Anything else?
I got a quick question. Have you ever done any reversing of Go binaries?
Yes.
Is it a real pain in the ass?
So the question was, have you ever done any reverse engineering on Go binaries? Isn't it a pain in the ass? No, it's not a pain in the ass at all, because unlike the rest of the civilized, quote-unquote, compiled languages in the world, Go, when you include a library, for now, this is on the list of things to do, and FLOSS people are pretty good about getting around to those things in this case, because it's not security related, and the only thing that the Go people hate is dynamic loads and security. The Go compiler will take a library and just include the entire library in your binary when you make it. And this is platform independent, so it'll do this on every platform. It makes the binaries really big, which is a giant pain in the ass. It also means that while Go binaries are relatively rare because of usage and because the language is very tightly controlled and doesn't allow dynamic loads, so unless you find a bug in the language, you kind of haven't found a bug. It's trivial to write shellcode because there's no ASLR, there's no resources moving around, and since everything is statically linked, you don't have to use the operating system to get your evil deeds done. You can just write your exploit and then jump to wherever you want in the language. And I've actually written proof of concepts where you can use the Go compiler to compile just a Go object, and you can manually jump to the object's entry point because the compiler will put one in there just in case, and call that code linearly as if you had a dynamically linking Go, even though that doesn't exist. So, yeah, the binaries are pretty easy to take apart. Also, the functions aren't stripped by default, and the function naming schema matches the human readable naming schema. So, unless something's packed or stripped, it's all very apparent. Yeah. So the question was how do Go threads work under the hood? I'm not enough of a Go expert to answer that entirely from memory, so I'll first answer by saying I don't know. I will tell you that what I do know is that it is not a direct call to whatever your operating system's version of the thread manager is. There are lots of reasons for this. One of them, oddly enough, is actually security. The Go runtime will enforce its own version of memory protection according to like NX stack style rules as available, and it will do this autonomously. So when you push dynamic data to things that it knows that are its responsibility, it will flag those non-executable, and it will change the execution types of memory all over runtime for you. I don't know that it never calls the system thread libraries, but I do know that it has the capability to manage those thread layers entirely in software. Whether or not it does them all the time, I don't know. Nothing else?
What's your GitHub?
My GitHub address is V as in Victor, Y as in yellow, R as in Robert, U as in underneath, S as in Sam, the number 001. It's virus 001. All right, I guess I'm done.